Robots have always been a popular topic over the past years. A lot of improvements have been made, but humans are not stopping at discovering innovations. Robots' functionality changed from just showing off mechanical prowess to making the lives of people easier. Robotics has changed from a simple path-following bot to a microbot that can be injected into a person's body to diagnose problems or even do surgery. But there is still more to come because the robotics technology we have now is not good enough for everyday use. Even though this can be changed in some ways, there are still more improvements to think about and make. In this video, we'll be talking about a revolutionary turn in the robotic industry. First of all, let's define what a robot is. In actuality, different people's definitions of robot vary. Even roboticists disagree on what constitutes or does not constitute a robot. And for the majority of us, our expectations of what a robot would look like and be able to achieve are heavily inspired by science fiction. So what constitutes a robot? A robot is an autonomous machine that is able to sense its environment, conduct calculations to make decisions, and perform actions in the actual world. This definition is neither overly vague nor too specific. Based on that, a robot is a machine made from inorganic materials, programs, and electricity. What if I tell you that there are robots that have organic components? They're known as biorobots. Biorobotics is typically defined as the technique of utilizing living organisms to build new technology. It is a broad topic that includes cybernetics and genetic engineering, and many new scientific advances are based on diverse biorobotics initiatives or projects incorporating biorobotics. Recently, there is a major progress in developing this kind of robot, and we will dive into it right now. U.S. researchers have made EBiobots, which are the first machines that combine soft materials, living muscle, and microelectronics. Integrating microelectronics allows the biological world and the electronics world, both of which have their own benefits, to come together, said Rashid Bashir, co-leader of the study and professor of bioengineering at the University of Illinois and dean of the Granger College of Engineering. These electronic biobots and machines could be used in the future for many medical, sensing, and environmental purposes. Bashir's group has been working on biobots for more than a decade. Biobots are small biological robots that are powered by mouse muscle tissue grown on a soft 3D printed polymer skeleton. In 2012, they showed walking biobots, and in 2016, they showed biobots that were activated by light. Light activation gave the scientists some control, but it was hard to send light pulses outside of the lab. John A. Rogers, a professor at Northwestern University and a leader in flexible bioelectronics, and his team were able to solve the problem by putting together tiny wireless microelectronics and micro-LEDs that don't need batteries. This let the researchers control the EBiobots from a distance. This unusual mix of technology and biology opens up a lot of possibilities for making engineered systems that can heal themselves, learn, change, communicate, and organize themselves. We think it's a great place for future research that could be used in biomedicine and environmental monitoring, said Rogers, who is a professor of materials science and engineering, biomedical engineering, and neurological surgery at Northwestern University and the director of the Query Simpson Institute for Bioelectronics. For the biobots to be useful, they need to be able to move around freely, so the researchers set out to get rid of the big batteries and wires that tied them down. Zheng Weili, an assistant professor of biomedical engineering at the University of Houston and co-first author of the paper, said that the EBiobots get their power from a receiver coil that sends out a regulated voltage to power the micro-LEDs. They move in a realistic way that they imitate the movement of an organism. Researchers can send EBiobots a wireless signal that makes the LEDs pulse. The LEDs make the light-sensitive engineered muscle contract, which moves the machine's polymer legs and makes them walk. The micro-LEDs are so precise that they can light up only certain parts of the muscle, causing the EBiobot to turn in the direction that was chosen. The researchers used computational modeling to figure out how to make the EBiobot as strong, fast, and easy to move as possible. Mattia Gazzola, a professor of mechanical sciences and engineering at the University of Illinois, was in charge of simulating and making the EBiobots. Gazzola and co-first author Xiaoyan Zhang, a postdoctoral researcher in Gazzola's lab, said that the scaffold's iterative design and additive 3D printing made it possible to do tests and improve their performance quickly. Youngya Kim, who did the work as a graduate student at Illinois and is co-first author, said that the design makes it possible to add more microelectronics, like chemical and biological sensors, or 3D printed scaffold parts to do things like push or move things that the Biobots find. The researchers said that by adding electronic sensors or biological neurons, the EBiobots would be able to sense and react to toxins in the environment, biomarkers for disease, and other things. Lee said, "By making the first hybrid bioelectronic robot, we are opening the door to a new paradigm of applications for healthcare innovation, such as in situ biopsies and analysis, minimally invasive surgery, or even cancer detection inside the human body." So, what do you think of this new invention? Do you think this will have a big impact on our society? Please leave your answers in the comment below. We want to hear from you, and your thoughts are always welcome. Thank you so much for watching this video, and please leave a like if you enjoyed it. You can also subscribe so you will now miss future uploads. As always, stay awesome and see you in the next video.